Thanks for the introduction. So I'm Robin Sommer. I'm a researcher at the International Computer Science Institute in Berkeley, California, and I'm also spending a little bit of my time at the Lawrence Berkeley National Lab working with the operations team there. Maybe I'll start with just asking, who has heard of Bro before? Raise your hands. Not that many. OK. So I'm trying to basically give an overview talk. Bro's a very kind of complex system. It can do a lot of stuff, so 30 minutes is a bit tight, but I'll see what I can do. So let me actually start by explaining a little bit at the high level what is Bro actually. And as I saw that the title for this track is actually attack and research, I think. And the previous talk was faithful to the attack part. I suppose research applies to me because Bro is really a defense tool, right? It's an operational defense tool, but it's coming out of academic research. So there's a lot of kind of work going into the system over the years. So one way to explain what Bro is actually to look at a few other tools first that network operators and security incident responders typically use in their daily operational life. So they often use something like TCP maybe for capturing packets, actually looking at what's on the wire. Then maybe Wireshark to look into the protocols, see what actually is there going on at the protocol level. They might be using something like Snort for finding attacks. And then usually some kind of logging is carried out, like recording the net flow or syslogging. And then, and that is an interesting observation, most administrators and operators use some kind of additional scripting tool to kind of tie these together, or do post-processing, do kind of crunching on the data they record, and are getting all of these tools, right? And that gives you like flexibility, abstraction, and data structures. So one way to look at Bro actually is to kind of draw a line there. And Bro is providing within a single system all these layers you see here. Bro is doing packet capturing. Bro is doing traffic inspection at the protocol level. It can find attacks, and it does an extensive amount of log recording so that you actually get an archive of what's going on your network. The most important point, however, is that actually Bro comes with its own scripting language built in. It has its own domain-specific language, which provides kind of the right idioms for this kind of setting, and that allows you to kind of tie these layers together in a way you couldn't do if you just have all these separate tools. And in that way, I often say Bro is a little bit like a domain-specific Python. So it's a different language, to be sure. It's not Python, but it has this flavor of you can build stuff with it, and you get a lot of standard functionality, like the Python standard library coming with the system already. Right? And another way to say kind of the same is Bro is really a platform. And this is kind of the high-level overview. So what you do is you tap your network, like with any PCAP-based application. You get the packets out there, and Bro starts processing those packets, looks at the protocols, and then you get this programming language, the standard library, and then on top of that, you can actually build applications. And the traditional application is intrusion detection. We used to call Bro IDS. We kind of are not doing that anymore. One is because IDS just confuses people. They think Snort, but Bro is really quite different. And the second is, well, you can do much more with this platform, right? So you can do vulnerability management, file analysis, traffic measurement, traffic control, compliance monitoring. All of that you build basically by writing scripts on top of this platform. Now let's switch. So before I go into more details, the other question I often get is, so who's actually using it? And I said it's coming out of research. And universities, research labs, supercomputer centers is kind of the traditional user base. But these days, it's actually a very diverse. So there are lots of government organizations, CERTs often are using it for monitoring. And these days, also like Fortune 20 enterprises. So we have a widespread deployment base now in the commercial sector as well. Some institutions I can call out are the Lawrence Berkeley National Lab, NCSA, the National Center for Atmospheric Research. And as a university, Indiana University in the US is actually running one of the largest setups. For those who want to try it, the easiest way is actually to download Security Onion. That is this security-focused Linux distribution, like a live DVD. Essentially, you just plug it in. Bro is pre-installed there, and you can immediately get to its log files and play with it. We do these annual user meetings. You see an example here at NCSA. I think there was the 2011 one, and usually there like 50 to 80 operators from 30 to 40 institutions showing up. And that are all usually incident responders. So these are the people actually using the system operationally day by day. So I'm going to break the rest of the talk into three parts of what Bro can do for you. One is log files, produces a record of what's going on your network. Second is alerts, it can notify you of interesting stuff. And third, you can customize it. Let's look at the first one. And I heard that the US Army is actually calling these log files coming out of Bro the network ground truth, because it records what it sees on the wire, independent of whether you trust the end systems, independent of they do any logging, independent of you can actually instrument them to do something for you. It just records what's there. That's the ground truth. Let's look at some command lines and some actual logs. So the easiest way to run Bro is actually it's a Unix-style application. So you run it from the command line in the simplest mode. You give it an interface, and then you wait for a little bit. It crunches the packets on the wire, and then you get a bunch of log files coming out of it. And you see some are called like protocols, and I'm going to look at a few of them in the following. They all are by default just ASCII logs, so they are well structured. If you look at one of them, the Conrad Lock, basically you get a tab-separated format, lots of column. I'm cutting that off on the end here. And each line in this Conrad Lock in particular is one session as it was on the wire, like usually one TCP flow or a UDP session. And in the following, I'm going to look at a few more of these logs, and I'm kind of, because they are so wide that it hardly fits the slide, I'm going to just look at the column. So here's a single entry of this Conrad log. And this is, again, what you get for every connection on the wire. So what Bro logs is a timestamp. That's Unix second since the epoch. It assigns a unique identifier to every connection, which is then used to kind of pivot across the log, so you can kind of identify later other activity relating to this log file. You get the IP addresses, you get the protocol, you get the application layer service, SMTP in this case. Interesting here is that is independent of protocol. So Bro actually looks at the content. Independent of ports. Bro actually looks at the content of the payload to figure out that this is an SMTP session. It doesn't matter which port that is on. You get the duration, you get the bytes being transferred, you get like a history of the TCP level flags. And the last one here is interesting. Tunnel parents, in this case, it's empty, but Bro can actually detunnel things like IP and IP or Toredo, right? So it doesn't care whether this SMTP session would be tunneled over something else. It just strips out the outer tunnel layer and then goes into it as HTTP. And in that case, you would see here the unique connection identifier of that outer tunnel connection. So it's kind of the most simple log. A little bit like NetFlow, but it's actually bidirectional, and you get one well-defined entry per connection. HTTP.log is another one. So for every HTTP request on the wire, you get one entry like this, right? And it's again a timestamp. It tells you which connection that was on. The IP addresses again. This was the post, and the host, the URI, referrer if there were any, and so on. If you look at the ones down here, it also looks at the content of that HTTP session, and it tells you, wow, this was XML. Currently, we're using libmagic for that, though we are probably switching to something else. So again, for every HTTP session, you get that. You also get the status code, so you see basically what the server said to that. So the point here is both sides of the TCP session are actually correlated together and produce a single log file. SSL.log. For every SSL session on the wire, independent of port, you get a breakdown of well, timestamps, IPs again, then the ciphers being in use, the certificate, the more timestamps for the certificate, and also actually Bro hands the certificate as it kind of grabs it off the wire onto OpenSSL to check it. So it get an indicator whether that is a valid certificate. To show two examples of kind of more enterprisey internal protocols. One is syslog. So we have a syslog analyzer in Bro, which basically picks up all syslog communication on the wire and puts that into a log file. So what you get is, for an SSHD session, for example, which normally would be sent to the central syslog server, well, accept the public key for this user from this IP address. It's kind of cool because actually you don't need a syslog server anymore. If you control the network, you just grab the syslog messages off the wire. DHCP log, kind of same scheme again. This time you learn basically the MAC addresses which are associated with an IP address, or basically what the DHCP server hands out. So every time there's a new lease, you get a log entry. So far these were basically protocol-based log files, right? So a certain protocol, you get a certain output. The next two examples are stuff which aggregates information out of multiple protocols into a single place. And there's one software.log. So various protocol analyzers in Bro can identify a certain software being in use. There could be a user agent on an HTTP session. As you see here, basically it tells you, okay, I have seen an HTTP browser with a user agent named Dropbox desktop client from this IP address. You also get that from SMTP, for example, the user agent. Or you get that from an FTP server, basically what the banner message is. So it aggregates this, and you can kind of dig through them later and see, okay, which client system on my network was running which software and which version at that time. And my last example for the log files, and this is a recent capability and probably one of the most powerful things we have recently added to the system, is a files.log file. So many protocols can transfer files in one form or the other. There's HTTP, obviously. There's FTP. There's email attachments, SMTP. Right? And Bro basically picks out all these files, the actual file content, and then passes this on to its file analysis subsystem, and then parses the file internally. So what it gives you is, well, the timestamp, and then it assigns unique file identifiers in this case, similar to the unique connection identifiers. It tells you which hosts were involved with that, which connections, where it's coming from. So this is out of an SMTP session. So there was an email attachment. And it does the MIME type detection, which I showed earlier already for the HTTP stuff. So this was an executable. It was an executable attached to an email. And it actually computes the hashes over the file content. So now you can take these hashes and go to some blacklists, for example, which gives you like a list of known malware, something like that. You can check that, and I'm actually going to show that later. You could also, this is the last line here, you could also extract the file to disk if you wanted. You can either kind of select certain files, maybe all executables. If your network is small, you could just record all the files if you want them, which is actually pretty cool from an operator perspective, because suddenly, well, you have all the executables some user in your network transferred. You have it on disk, and you can run your AV stuff on it, for example. So that was the last log file. One thing many people use these log files for is actually understanding the network better, because suddenly you can do like a bit of crunching on them, and you can kind of do statistics. Here's a very simple example using the files.log I just showed. We have this tool called BroCut, which picks out certain columns out of these tab-separated formats. In this case, I take just the MIME type. I sort it, unique it, sort by number. And what you get is a breakdown of what are the MIME types transferred in your network in terms of files. I left off the numbers because this is very network specific. So every network looks differently, of course. But these kind of statistics are really helpful often for operators, because you suddenly get an idea what are your people actually doing. And you can use this kind of style of analysis on all these logs. So it's easy to aggregate, basically, on all these features I've showed earlier. Second example is, what is the top software being used in my network in terms of number of hosts? Command line is a bit more complicated, because now you need to aggregate by a two-tuple, essentially, and unique in between. But you see the distribution of, in this case, mostly browsers, because in this network, most of the traffic is HTTP traffic. And you see Chrome is probably here the most popular browser, followed by the other ones, and some update stuff, crypto stuff. So this is what people often just do on these log files. And that concludes my log file part of the talk. The second part is alert. So Bro can obviously look for interesting stuff and send you an alert. That's the ideas part. All the alerts get recorded in their own log file, again structured in this ASCII format that I showed, and you can trigger actions. So some people are automatically blocking all the scanners, for example. So they interface it to their firewall and just putting blocks in place if they find something. These are all the alerts Bro by default can generate. And I'm going to talk about the 4.1 as examples, which are in bold. So let's start with something simple. And that is just like a very simple, or two simple heuristics for finding suspicious SSH logins. One is, so for many sites, it turns out that they rarely have logins from other countries. Particularly applies to the US. Or maybe the source countries they see SSH logins from is kind of well contained at least. So Bro can easily watch for countries people log in from. So every time there's a successful SSH login, there's a geo IP lookup, matches that against some blacklist or whitelist, whatever you like, and basically can generate an alert. Second heuristic is the interesting hostname login. So observation is that if somebody from external is logging into your site, and that SSH login comes from a system with a DNS name, for example, of SMTP dot something. Well, that's kind of odd for most systems, right? I mean, an SMTP server from external should not really log into your network. Most likely that SMTP server is compromised, and somebody's kind of using this as a hop to get into your network. Again, simple heuristics, actually pretty effective, has found a number of compromised systems, or potentially compromised systems as these logins come in. More interesting, more sophisticated is intelligence integration. So basically, this is the basic setting. You tap your network, Bro starts looking for stuff, and you can define this stuff very flexibly in the sense of that you can give it intelligence, like blacklists of IP addresses, blacklists of bad DNS names, URLs, file hashes. Basically, all these, there's various sources of feeds on the network. CIF is the collective intelligence framework, which in the US is a list of feeds distributed among the universities. JC3 is Department of Energy kind of feed of bad stuff, and Spamhaus and many enterprise customers actually have custom or proprietary feeds. So you can take these blacklists, put them into Bro. And then the interesting thing is, now Bro starts monitoring for these things basically everywhere where an IP address or a DNS name shows up. So in HTTP, for example, there's the server header, right? That's a DNS name. A DNS lookup, of course, DNS response, of course. SMTP in the received line, there's a DNS name. So wherever one of these blacklisted DNS names shows up, Bro flags it. This is an example alert. In this case, you see the was between these hosts. It's a notice related to the Inter framework. This was the bad domain being found, and it's actually coming out of the HTTP host header. And the feed I was putting in here was my private feed. So, and this works all in real time. So you can update this list of blacklists in real time. Basically, you can, easiest way is to just put it into a file, and every time you update the file, Bro, as it works, as it processes input, Bro just picks that up and updates internally at data structures. So you can basically continuously download these feeds and just keep monitoring for them. Just for reference, these are all the places where these intelligence pieces are being searched. So you see the HTTP host header in there and lots of other ones. I call this passive intelligence integration in the sense that, well, you provide the data outside of Bro to Bro, you put it on disk or something. There's another version of that, which is active intelligence integration, where Bro actually goes out on demand and looks for stuff. And you guys might know the Team Camry, the malware hash library. You can basically have the hash of a malware, and you ask the hash library via what did I say? You have the hash of the malware, and you ask via DNS, you ask the malware hash library, is that bad? Basically, do you know about this? Is this bad stuff? You could do that manually by essentially getting the hash files out of this files.log and doing digs, but actually Bro can do that in real time. So as Bro finds a file, you can tell it to do a DNS lookup with the malware hash registry, and every time there's a hit coming back, it actually logs that. So that is the alerts part, and my final part is the custom logic part. And this is, so a colleague of mine actually usually says, he tells people, don't ask what Bro can do for you. Think about it in the way, what do you want it to do? And this is really where the real power comes in. And this is where 30 minutes for a talk is actually kind of short. So I'm just trying to give you a quick flavor of this part. Let's say your task is you want Bro to find all web requests of this strange thingy there, .troopers. Maybe that's the news malware. Right? Here's how you do that in Bro script code. I said earlier, it's a programming language. It's an event-based language. So what you say is every time there's an HTTP request on the wire, you get all the meta information with that. So basically, what's the HTTP method? What's the URI being requested? And then you do a little bit of code. This is Bro scripting language. And in this case, this is straightforward. It's almost Snort style signature matching, right? So every method, which is a get, you try this regular expression here. And if it matches, you raise an alert. This is the internal function, which kind of hands it off to the notice system. Another colleague of mine about this one likes to say, as interesting as what you see here is what you don't see. So all you write is, for every HTTP request, please do something. You don't need to care whether that's on port 80, whether that is maybe inside a tunnel connection. You don't need to care about the TCP reassembly going on. So basically, you get this abstraction of these key steps, which you can just then use to express your stuff. And my second and last example is just a simple scan detector. Say your task is count the failed number of connection attempts per source address. So that's really just like one IP address probing your network, right? And this is kind of the most basic version of how you could implement that in Bro scripting language. In this case, you keep a global table. That's like a hash table in Perl or in Python, right? And you index it by addresses, and you map it to the number of failed accounts, of failed attempts so far. So now you say for every connection rejected, which is basically erased by Bro this event, every time there's a TCP session somebody tried to set up and was rejected with a reset. So every time that happens, this code runs. And you basically take the originator address, which is in this connection record here. Don't get confused by the dollars. That's just a dereference operator, like the dot in C. Just for syntactical reasons, it's a $sign here. So you take the source address, you increase the counter, and if there's a threshold reach, alert. In practice, the scan detector is much more complicated because there are lots of corner cases and different things you want to watch for. But the flavor here is, this is very typical for Bro scripts. So you remember stuff over time. As these events come in, you can start correlating different kinds of events together. You can, for example, count HTTP requests here if you wanted. Right, so in your keep state, remember things, you check occasionally, and you generate alerts, notices whenever something interesting is there. Bro comes with more than 10,000 lines of this kind of code pre-written. That's the standard library I was talking about at the beginning, right? So that's just loaded. You get that out of the box. And maybe the main thing to realize here is basically all this output I showed you so far and all these alerts I showed you so far is really just Bro scripts. There's nothing hard-coded into the Bro system about how these log files look. Which means you can write your own, or you can generate your own log files. You can customize them. You can exclude columns. You can include additional columns. It's all flexible. You can generate your own notices the same way. And there's a growing community writing third-party scripts. Last year, there was this APT1 record by Mandiant. For those who know it, Bro had basically support within a day as the only system that quickly to look for these indicators, which Mandiant reported there. So there's so much more I could talk about. I'm running out of time, so just basically my main message here is Bro is really a platform. So it supports all these applications. I focused on the intrusion detection part, although the compliance monitoring is actually much just looking at these log files. Maybe somebody's running software he's not supposed to run, which is vulnerable, it hasn't been patched, and your compliance requirement might be you have to run patched software. Lots of more interesting stuff. I'm around tonight, tomorrow, if anybody wants to talk about any of these other things here. And otherwise, I just want to thank the National Science Foundation because they actually have, with their funding, enabled much of this work for many, many years now. Contact information for the Bro project. We are on Twitter, still the Bro IDS handle, because it's hard to change, or Bro is taken. And actually, a recent development, we are offering commercial support these days. So there's a company called Broala, founded by the key members of the Bro team, which works with enterprise and government customers. If anybody happens to see Gilbert, maybe point him to Bro. Might save them some time and effort. Thank you very much.